Welcome back to my new video. Myself Vishnu Ratan, we studying in Venkateswara College of Engineering. Today's subject is Principles of Programming using C. Topic is Introduction to C Programming. Introduction to C Programming. C programming language was developed in 1972 by Dennis Ritchie at Bell Labs. It is a powerful and efficient programming language used for developing system software, application software, and embedded systems. C is a general purpose language known for its speed, flexibility, and portability. Why learn C programming? Learn C programming enhances problem solving skills and logical thinking. C is the foundation for many other programming languages like C++, Java, and Python. Understanding C allows programmers to have a deeper understanding of how computers work at a fundamental level. Setting up the C environment. To write and run C programs, you need a text editor and a compiler. Popular C compilers include GCC, Clang, and Microsoft Visual C++. Integrated development environments like Code Blocks, Dev C++, and Visual Studio provide a user-friendly environment for C programming. Basic structure of a C programming. A C programming consists of functions, variables, statements, and expressions. The main function is the entry point of a C program and must be defined in every C program. Statements in C are terminated by a semicolon and curly braces. Define the scope of function and control structures. Data types in C. C supports various data types such as int, float, double, char, or data types determine the size and type of visual that can be stored in variables. Declaration of variables in C involves specifying the data type and the variable name. Variables and consonants. Variables are used to store data that can be changed during program execution. Consonants are used to store fixed values that do not change during program execution. In C, consonants can be defined using the constant keyword. Operators in C. C supports various operators such as arithmetic, relational, logical, assignment, and bitwise operators. Operators are used to perform operations on operands to produce a result. Operator precedence and associativity rules determine the order in which operators are evaluated in an expression. Control structures in C. Control structures like if-else, switch case, and loops are used to control the flow of execution in a C program. Conditional statements like if-else allow for decision making based on certain conditions. Loops allow for repetitive execution of a block of code until a certain condition is met. Functions in C. Functions in C are blocks of code that perform a specific task and can be called multiple times within a program. The main advantage of using functions is code reusability and modularity. Functions in C can have parameters and return a value. Arrays in C. Arrays in C are used to store multiple values of the same data type under a single name. Array elements are accessed using indices starting from 0. Arrays can be one-dimensional, multi-dimensional, or array of pointers in C. Strings in C. In C, strings are represented as arrays of characteristics terminated by a null character. String manipulation functions like strcpy, strcat, strlan, strcmp are commonly used in C. C does not have a built-in string data type, so strings are typically handled as character arrays. Pointers in C. Pointers in C are variables that store memory addresses of other variables. Pointers are used for dynamic memory allocation, accessing hardware, and passing arguments by reference. Pointers arithmetic allows for efficient manipulation of memory locations in C. Structures and unions. Structures in C allow the creation of user-defined data types that can hold multiple variables of different data types. Unions in C are similar to structures but share the same memory location for all members. Structures and unions are used for organizing complex data structures in C programs. File handling in C. File handling in C involves reading from and writing to files on the disk. Standard functions like fopen, fclose, fread, and fwrite are used for file operations. C supports text file handling and binary file handling for data storage and retrieval. Preprocessor directives. Preprocessor directives in C are commands that are processed before the actual compilation of the program. Directives like hash include, hash define, and hash if diff are commonly used in C programming. Preprocessor directives are used for file inclusion, macro definition, conditional compilation, and debugging. Dynamic memory allocation. C provides functions like allocation, M allocation, C allocation, read allocation, and free for dynamic memory allocation and deallocation. Dynamic memory allocation allows programs to allocate memory at runtime as needed. Proper memory management is essential to prevent memory leaks and optimize program performance. Error handling in C. Error handling in C involves identifying and responding to unexpected situations that may arise during program execution. C provides mechanisms like return values, error no, and p error for error handling. Expectation handling in C is typically done using conditional statements and error codes. Error handling in C modern programming language provides support for error handling. C, however, provides limited error handling in the form of returned values. Most of the times, if a functional returns null or the value 1, it means that an error has occurred. Best practices in C programming. Follow coding standards and conventions to write clear and maintainable code. Use comments and meaningful variable names to enhance code readability. Always validate user input and handle errors gracefully to prevent program crashes. Debugging and testing in C. Debugging tools like GBD, WellGrid, and IDE debuggers help identify and fix errors in C programs. Testing methodologies like unit testing, integration testing, and regression testing are used to ensure program correctness. Through testing and debugging are essential for producing robust and reliable C programs. Conclusion. C programming is a powerful language with a rich history and a wide range of applications. Mastering C programming provides a solid foundation for a career in software development and system programming. Continuous learning and practice are key to become proficient in C programming and leveraging its capabilities effectively. Thank you for watching.